Here we go. Another fun one for you to try and think it through. So here I have a spherical, convex, thin lens with the object inside the focal length. We have our principal rays here that we want to draw, and I've labeled the focal points of the lens here. So I want you to quickly write down what you think DO and F are, in particular the signs. So again, tick marks every 10 centimeters. So give it a shot. I'll give you the answers in 3, 2, 1. So this is that's 30 centimeters. This is the front side. So it's positive. This is the back side. Now, if a lens is fat in the middle, if it's convex, focal length is positive. So this should be a positive focal length. And it looks like it's 10, 20, 30, 40 centimeters. Fat in the middle, lens, positive focal length. Another way, if you know what it is for mirrors, it's whatever. There's lots of ways to remember it. I remember it this way. If the lens is fat in the middle, if the lens is convex, focal length is positive. The other one's negative. All right. So if you want to try and draw the ray diagrams based off the last video, maybe you can do it. Pause the video, give it a shot. I'm going to do ray 1 in 3, 2, 1. Here we go. In parallel, out through F. In parallel. I'm going right to the middle, right? So imaginary dotted line right there. Okay, in parallel, and then out through F. So if I'm going through I use the focal length on this side for a convex lens. F is positive, backside is positive. I'm going through this focal length. Ray 1, we're always using that. I should be careful. Ray 1, we're going to draw it this way for this type of lens. Okay. Now, back extend the output. Okay, and I'll label this on this side just so I have room. Ray 1. Ray 2. Pause the video if you want to try it. I'll do it in 3, 2, 1. In through the focal point, out parallel. So we're going to use the other focal point, right? Ray 1 uses this focal point. Ray 1 uses the focal point that matches the sign. So for lens, the backside's positive. Ray 1 uses the positive side, which is the backside. Ray 2 uses the other focal point. It says if light went this way, just barely able to get it. If this ray comes here, now think, it's like going into a prism. It's going to be bent, comes out level. Ray 2. Back extend the output. Ooh, they're not going to meet up unless I keep going. It's not going to be the last time you have something like that happen. Hopefully they'll meet up if I go that far. Just barely. So the image is real or virtual? Think. The image is, so let's just write down the image from the ray diagram. And the height of the image. Okay, what is this going to be? About 10, 20, 30, 40, 50, 60, 70, 80, 90. height of the image is about 37. Positive. It's upright. It's on the same side of the optic axis. And that looks like it's 10, 20, 30, 40, 50, 60, 70, 80, 90. Ooh, let's just say 99. Positive or negative? It is negative. All right. And then one last diagram. We'll worry about the pen cap some other day. If you want to pause the video and try to do it yourself, great. In through C, travel straight through. Here, C means center of the lens. All right, so it's going to come this way and travel straight through. That's ray 3. I probably should write it that way. In through center of lens. Back extend. It's looking like it's going to meet up. Pretty close. Not bad. That's how you do that one. All right. You could check the numbers and see if you get, I don't know. Again, these numbers are not exact. You can try and do the 1 over F math and see if it matches up.